Welcome, everyone. Now we're going to look at how to represent functions by using the geometric series. So let's recall that the geometric series is a series of this form. So you have the sum starting from n equals 0 to infinity of x to the n power, which can be expressed as when n equals 0, you have 1, then the next term is x, plus the next term is x squared, and so on. And this we know converges to 1 over 1 minus x, as long as x in absolute value is less than 1. So we know that. So our goal is to represent these two functions right here in this particular form so that we know how to write it as a closed formula. So let's go ahead and do that. So for the first one, A, we want to manipulate this formula so that it looks like this. We want 1 over 1 minus x. That's what we want. So let's see how we can do that. So we have f of x is equal to, so I'm going to pull the 2 out. So we have 1 over 3 minus x. Now we want this to be a 1. So we're going to factor out a 3. So on the denominator, so you have 2 times 1 over. If I factor out a 3, so I have parentheses, then we have 1 minus. And if I factor out a 3, then I must also divide this term by 3. So you'll have x over 3. Okay, now that looks like the form we wanted. Now let me go ahead and rewrite this. So this is really 2 over 3 times 1 over 1 minus. So here you have x over 3. So that's kind of like the x we have up here. So as you can see, we have that exact form, 1 over 1 minus x. So here's 1 minus x, but in our problem, x is x over 3. So we can make the direct substitution. So this piece right here, this is equivalent to, so we have 2 over 3 in the front. That highlighted portion is the sum starting from n equals 0 to infinity of x to the n power, but our x is going to be x over 3. So that's the substitution we make, and that is our representation. So of course, this is centered at 0. Now let's simplify this so that it looks a bit nicer. So we have 2 over 3 times the sum from 0 to infinity. We have x to the n over 3 to the n by using the laws of exponents. And then here I can pull this coefficient inside the sum. So we have the sum starting from n equals 0 to infinity, x to the n over 3 to the n. And if I push that coefficient inside, I have 2 over 3 right here times x to the n over 3 to the n. Now here again, by using laws of exponents, you can combine these. Same base, we add up their exponents. So our final answer, we will have the sum starting from n equals 0 to infinity. You have 2 times x to the n over 3 to the power of n plus 1. So that is the representation, the power series representation of this function, 2 over 3 minus x. So here's the second one. Again, your goal is to write this as 1 over 1 minus some kind of x, because this is equal to the sum from n equals 0 to infinity of x to the n power. So we know that. And we're going to rewrite this in this specific form. So let's see how we can do that. Again, we need to manipulate algebraically. So we can take out the x. So on the numerator, we have a 1 over. Now the denominator, I can rewrite the plus as, so we have 1 minus x to the third. So that's kind of like our x, the replacement right here. So then the power series representation of this piece is going to be the sum starting from n equal 0 to infinity of some x to the n. So in this problem, our x is negative x to the third power. And then by using laws of exponents, we can simplify or clear out the inside. So we have x times the sum from n equals 0 to infinity of negative 1 to the n, because we have a negative 1 right here. And then x to the 3 to the n, that's x to the 3n, 3 times n. Now here we can combine this and that. So I can pull the x inside the summation and combine them by using the laws of exponents. So here you can pull this inside. So our simplified answer, or a nicer form, is the sum from starting from 0 to infinity, -1 to the n, times x to the power of 3n plus 1, as you pull one factor of x inside. And that will be it. That is our power series representation of this function. All right, I hope this makes sense. Take care.